We're going to start Chapter 6 soon. This is some preliminaries that you need to know for Section 6.1 and 6.2. We'll be doing composition of functions and determining the domain and range of functions and inverse functions. Okay, we're going to start out with evaluating this function. Our function is y equals 2x. And what we're going to do is just evaluate with these domain values here. So I'm going to say evaluate when x is negative 2. So we get 2 times negative 2, and that equals negative 4. Alright, this is evaluating. F of negative 1 equals 2 times negative 1, which is negative 2. So everywhere there's an x here, I'm inputting my domain value. F of 0 equals 2 times 0, which equals 2, which equals 0. And f of 1 is 2 times 1, which equals 2. And 2 times 2 would give you back to 4. Okay? Now, do you all remember how you find the inverse functions? What you first do is switch the x and the y. So I'm going to take this function and switch the x and the y. So we get x equals 2y. I solve for y, so I'm going to divide both sides by 2, and I get y equals 1/2 x, or x over 2. So this is my new function, but this is my inverse function. Okay? So we can write this as f inverse. Some mathematicians just leave it like that, or you could actually add the x. Okay. So, also, since we switched the x and the y here, all we have to do is switch the x and y from the previous page. So before we had negative 2 here, and that went to negative 4. Negative 1 went to negative 2, 0, 0. Then we had 1 and 2. So this went to 2 and this went to 4. So what happened is my domain, so the domain of f equals the domain, or the range, equals the range of f inverse. And the domain of f inverse equals the range of f. Alright? All this is saying is I switched my x and y here, and so my domain and range switched. That's all it's saying. Now, the main concept you need to know involves composition of functions. Okay? It depends on what algebra teacher you had if you did a composition of functions. Alright? When you have f inverse composed of f of x, if they're inverses, it equals x. And x belongs to the domain of f. If I compose f with f inverse, then x, the domain belongs to, x belongs to the domain of f inverse. This is a different way of writing the same thing. So you can write it this way, or you can write it this way. Okay, this is the easier way to write it. This is more, this way is a more functional way to write it, especially if you're evaluating. Alright, So basically I'm going to show you how a composition of functions. So we know when we're composing f with f inverse, we should get x. And the same thing when we compose the other way. Alright, so this is how you do it. You're going to write f inverse of f of, and we're going to use our first x, which is what? -2. Well, what is f of -2? Well, f of -2 is what? -4. So I'm going to write -4 here because that's what that equals. Then I'm going to do f inverse of -4. Well, f inverse of -4 equals what? -2. So we're back to the domain of x. Let's do another one. Let's do f of 1. F inverse composed with f of 1. Okay, f of 1 equals 2 here. So this equals 2. And what is f inverse of 2? When you go up to here, f inverse of 2 equals 1. So we get back to the domain value. And we can also do it the other way. Now our domain here for f inverse is -4. So I'm going to try that first. I'm going to say f composed with f inverse of -4. Okay, f inverse of -4 is -2. F of -2, we come back to this first one here. F of -2, we notice is -4. So we come right back to this. Let's do this one. So we're going to compose f with f inverse of 2. Well, f inverse of, whoops, not 2 but 4. Alright, so 4, we know f inverse of 4 equals 2. And what is f of 2? F of 2, we're back to here, and we come back to 4. All this is saying is that when you compose it, you're back to the domain of f inverse. So the domain of this one, x belongs to the domain of f inverse, and when you compose this way, x belongs to the domain of f. These are your domains. And real quick, we're going to graph the two functions. We're going to graph y equals 2x. So y-intercept is 2. Go up 2 over, whoops. Go up 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. So let me try to draw this. Okay. So this one is y equals 2x. And now I'm going to graph y equals 1/2 x, which is up 1 over 2, up 1 over 2, down 1 over 2. So I'm going to do one more. Down 1 over 2. So this one is y equals 1/2 x. And you should notice that f and its inverse, this is the inverse, reflect over the line y equals x. So this is y equals x. Let me get through here. So this is y equals x. Reflects over y equals x.